One way to ensure that you fortify your networks and your hosts is to have an awareness of common attacks, one of which is a zero-day attack. Now, a zero-day attack is called such because it means that we've got some kind of a vulnerability that was discovered either by a malicious actor or by a security researcher, but that vulnerability is not even known by the software vendor or the hardware manufacturer, hence zero-day. So if even the vendor doesn't know that that is a problem, you can imagine it's being exploited in the wild and there are no updates available because no one really knows about it. So there is something called the Zero-Day Initiative to counter this, the ZDI. Now, the idea with the Zero-Day Initiative is to promote the disclosure of discovered vulnerabilities for the overall good of the internet community, and also in some cases to receive a payment. There are some cybersecurity specialists that are really good at what they do that can make a living at this. Let's explore that just a little bit. So here in my web browser, I've gone to the zerodayinitiative.com site, where I'm going to click on find out how to disclose these types of vulnerabilities in a responsible manner. And when I do that, I can read about the program benefits and how it is disclosed to this initiative. And in some cases, with payments. Now, let's talk about the payment side of it in another aspect. Here in my web browser, I've searched for bug bounty programs, bug bounties. What's that about? Finding bugs or vulnerabilities. Big companies, as we see here, like Intel. If we go a little bit further down, Yahoo. What else do we have here? Snapchat, Cisco, Dropbox, Apple, Facebook. You get the idea. These companies, it is in their interest to make sure that any discovered vulnerabilities are addressed immediately. And they pay big bucks for it. Again, there's a way to make a living doing this. You can imagine, in some cases, getting bug bounty payouts in the tens of thousands of dollars, or in some cases, hundreds of thousands of dollars. So it's important then that we have an understanding of 0 days. Just because we have all of the latest patches applied and our anti-malware is up to date, we don't want to fall into a false sense of security thinking, oh, we're good. There is no way we're going to be compromised. That is a false sense of security. Now, that doesn't mean we shouldn't be applying patches and we shouldn't have a virus scanner up to date. We certainly should, but that's not the only part of the picture. Now, other common attacks, to be more specific than just saying a 0 day, would include things like DNS sinkholing. Now, normally DNS is used to resolve names to IP addresses. Everybody depends on it because no one remembers the IP address for the Twitter website, but we sure know what to type in for a URL, and in case of launching an app, it'll do that for us. But what if those DNS results sent back to a client are tainted? What if a malicious actor has somehow modified the DNS return result to redirect you to something that looks like the real deal, but it's not? Whether it's for Twitter, whether it's for online banking, or whatever the case might be, that is a security problem. So that comes in the form of DNS sinkholing. Privilege escalation is really just a generic term in cybersecurity that talks about once a system is compromised, somehow getting a privilege escalation in that device. It might mean gaining root access by cracking into a network initially, running an Nmap scan, finding a Linux host, and then cracking the root password because the password hash is insulted, or maybe because it's a simple password. So in that way, we have privilege escalation from gaining access to the network to ultimately gaining root access to a Linux host on that network. There's also replay attacks. As you might guess, this would mean capturing something that's happening on a network conversation, whether it's a secure cookie for a secured website, or whether it's actually capturing network traffic, making changes, and sending it back out on the network. Now, those are often called man-in-the-middle attacks or on-path attacks because we've got some malicious entity in the middle of a connection to a secured site or network communication, and they're making a change and sending it off elsewhere. Now, some of these common attacks are more specific to software development. So if you're a programmer, you might know about secure coding guidelines that can help reduce this from happening. Pointer and object dereferencing. What this really means is attackers can manipulate memory pointer locations. And in some cases, if you can manipulate what is being returned from what's in memory on a server, you can start to return sensitive information. Or if you can write to locations in memory that normally shouldn't be written to, you might crash a server. So that would be a denial of service attack. So there are some exploits out there that even script kiddies can just execute against hosts to do this. But normally this is created by a software developer that knows exactly how to manipulate pointers at the code level. The other thing to think about is error handling. Again, software development and also script writing. You can catch errors and do something when you catch an error event in your code or in your script. But if that's not handled correctly, one of the attacks related to that is kind of off to the side. And what I mean by that is your code or your script might capture errors correctly and do something about it, but it might disclose too much information. An example of this is connecting to a website and trying to authenticate as a user, and the error message that comes back tells you the password's incorrect. Okay, so the username's not correct, so I know half of what I need to know then. Or I've seen cases where you connect to poorly designed websites where you try to authenticate and it fails, and it actually returns a SQL database statement where it's trying to authenticate you against a back-end database. That's too much information. TMI. Attackers will use that. And that's what we're getting at when we talk about error handling type of attacks. Then there's dynamic link library or DLL injection attacks. So first, what's a dynamic link library? Well, in a Windows environment, when you have a software application, a program, instead of it all being in one big giant executable, we have an executable program that is smaller, and depending on what the user is doing in the app, let's say they want to print, well, that executable will refer to functions in a DLL. It's like a function library that gets called upon when needed, depending on what's happening in an app. So what can happen is malicious actors, if they can gain access to the host, can place malicious DLLs on the machine that get called by applications, that can execute malicious code, capture keystrokes, do that kind of thing. Resource exhaustion. This one's easy because it's really denial of service or distributed denial of service if you have multiple hosts working against a network or a target website, flooding it with useless traffic. That's easy to do. You can write a script with a loop that floods a network with useless traffic so legitimate traffic is slowed down or doesn't even get through to where it needs to go. That can also result in things like memory leaks for poorly written code or malicious code written that way intentionally. It can cause a memory leak on a machine until there's no more memory and ultimately it crashes. Even unplugging a server, if you can gain physical access, that's a denial of service attack, as unelegant as it might seem. Finally, another programmatic phenomenon is something called a race condition, and this is specific to multi-threaded applications. Now, a multi-threaded application takes advantage of modern processors that allow you to have multiple pipelines, meaning you can have code written so that you have multiple instructions being processed simultaneously. But depending on what else is happening on the system, and depending on how the code is written, a race condition could occur where we have one code execution thread that finishes quicker than another one that it depends on. And so that can sometimes cause a problem. It can cause a crash, or it can sometimes cause some kind of a security privilege escalation by accessing points in memory that should normally not be made available. So race conditions then are based on timing. Okay, so for the Security Plus exam, be aware of some questions that might test indirectly, normally through a scenario, your knowledge of things like race conditions and zero-day attacks.